Shall we start, sir?
But the number is very minimum, not 26 only is there.
Great. 26 is only for Epic Hackathon participants. Remaining students, we have shared the YouTube link.
Okay. And I think everybody has joined, is it?
Many of them have joined, sir. Many of the students have joined.
Yeah.
Yeah, Sridhar, go ahead, I think.
Okay. So I'll ask my colleague Raina Dua to coordinate the entire activities. Yeah, Raina, please.
Good afternoon to each and everyone present in the meeting. I welcome our esteemed speaker, Dr. Chintan Vaishnav, Mission Director for Atal Innovation Mission, Dr. Geeta Vaini Raisam, Head HRDG, CSIR scientist, and all the students to the first popular talk. As you might be aware, the CSIR launched a new initiative empowering pupil innovation and creativity, that is EPIC, under CSIR-Jigyasa for school students on January 5, 2024. The program envisages providing a platform for budding student scientists to pursue their innovation and develop novel ideas under the mentorship and guidance of scientists. The broad themes for this year were One Health and Clean Energy. Applications were invited in the form of ideas, designs, prototypes, technologies, or smart apps for solving societal issues and improving life quality. We received more than 960 proposals from around 1,200 students. The submissions were reviewed by experts, and a total of 42 proposals from 64 school children were shortlisted. The shortlisted students have been earmarked to CSIR laboratories for immersive 2-month summer internship in hybrid mode under the mentorship of scientists from CSIR laboratories. As a part of EPIC Hackathon, CSIR HRDG has identified eminent speakers to talk about innovation, entrepreneurship, technological development, and to motivate students to be innovative. Today, we have our first talk of this series with Dr. Chintan Vaishnav. To begin with, I would like to request Dr. Geeta Vaini Raisam, Head HRDG, to deliver the welcome address. Ma'am, please.
Yeah. So good afternoon, everyone. And thank you, Raina, for the introduction. I think you have covered the spectrum of the activities we have planned under this hackathon. And I think just for the benefit of Dr. Chintan Vaishnav and the other students, so this activity was many times we get ideas and we evaluate ideas, but actually take from idea to translation. So it's not just coming up with an idea and let it go, but actually to give them an opportunity to translate this idea. So that's the reason why we identified suitable CSIR lab. And these students will work with them either online or offline, depending on and for 2 months, and they develop this idea actually into a prototype. So this was just to actually get them hands-on experience, real exposure. And we are also hoping to give some internship funds also, because we have got some corporate social responsibility funds as well. And we hope to give some internship support to the students. And at the end of it, we also plan to have an exhibition of the products or apps developed by the student and get some industries to come and visit. So this is just to promote the innovation, the spirit, which I think even Atal Innovation Mission is doing it. And so on similar, and as a part of this, we thought let them also hear from some of the innovation, experts in the country. What does it entail when you take innovation, and how can we promote this in the students? So this is an opportunity for the students to learn, and all the students have joined. I think many of them have joined. And again, I would like to thank Dr. Chintan Vaishnav for really accepting our request and being with us here. And I'm sure the students are excited to hear from you. And thank you again, and look forward to the talk.
Thank you, ma'am, for your kind words. Now I would like to invite Dr. Chintan Vaishnav to deliver his talk. To brief the audience about Sir, he is the Mission Director for Atal Innovation Mission, a flagship initiative of the Government of India under the auspices of Niti Aayog. Prior to joining Atal Innovation Mission, Dr. Vaishnav was the academic director of the Tata Center for Technology and Design at the MIT, USA. Dr. Vaishnav holds a PhD in Technology Management and Policy from MIT. As a teacher, innovator, and entrepreneur, he has first-hand experience of the various parts of innovation ecosystem, both in India and the US. Over the past decade, he has split his time between teaching and research at MIT and living and working with rural communities in India to build solutions that can overcome constraints fundamental to improving human conditions. He has co-founded both commercial and non-profit organizations. He has also advised startups, corporations, and governments on tackling challenges at the intersection of technology and systems, development, and public policy. Over to you, sir.
Thank you very much. Can you hear me all right?
Yes, sir. You're very much audible.
Okay, all right, great. Let me see if I can share my screen. Wondering how to share my screen. Looks like I don't have a setting people chat. Share. There you Okay, yes, I got
leave
it.
button, there is a share.
Yes, I got it. Yes, I got it. Let's see. Share content, share Windows. Let us see. Okay, about to share. And let's see. Your presenter. Can you see my?
Sir.
Is it visible now? Okay, great.
Just make it a slideshow, sir.
Is it? Can you see the slideshow now?
No, sir. Your screen has disappeared.
Oh, I see. Okay. Well, let's see. Just give me a second. Give me a second. I will just share the screen. Is this better now? Can you see the slideshow?
Yes, sir.
Yes, sir.
Yes, we can see. We can
Very
see.
good. Very good. Thank you very much. Well, greetings, everybody out there, all the students, innovators, participants. First of all, many thanks, CSIR, for giving me this opportunity to speak to the Jigyasa Hackathon, Epic Hackathon participants. This is a fantastic undertaking. And I am sure all of you who are participating will learn immensely from this opportunity. What I wanted to do was I wanted to give you a fast forward view of what I think you are going to experience as you go through this journey. Particularly, I wanted to emphasize some aspects that I see that I know that I would have loved to know as an innovator when I was starting out. So I'm trying to share those things with you. So I hope some of these things would be useful to you as you take your journey into becoming an innovator, an entrepreneur, etc. Before I share those some of those nuggets. Hello. Yes. Okay. All right. You can still hear me?
Yes, sir.
Okay. Good. Well, before I launch into this, I do want to share that I'm really delighted that these hackathons are happening now all across our country, and many young people are participating, because we really simply can't employ everybody through business as usual. You know, we have 700 million people under the age of 30, about 620 million people under the age of 25. If all of them have to earn a livelihood, be gainfully employed, etc., they will not only have to learn some or the other skills so someone can employ them, but they will also have to learn a way to solve problems and employ somebody else, right? So this whole idea of job creation, etc., in some ways begins where your journey of hackathon is beginning, where you see a problem, you want to solve that problem, and you want to do it in a way which is sustainable. So now what I've seen is there are three components of this journey. Articulation of the problem itself. We will talk more about that. Second is as you build your solution, iteration. So you may fail many times, and that's okay. You just fail fast and you try to improve, and so on. And so iteration is the second piece. And the third piece is endurance. No matter what problem you're solving, if this is an important problem, it is going to take you 5 to 10 years if you want to if you really want to have an impact on that problem, right? So I'm going to try to tell you these three pieces as we go along. Let me start us with this video. You tell me if you can hear the sound. Although the sound is not really important, but just take a look at this video. Okay, so what you saw was not it was this scene that you saw is from a high school in Bhiwandi district of Maharashtra. This is Mitesh. I mean, this school that you see is one of the relatively low resource schools in Maharashtra. And the welcome that Mitesh is getting is because he has won the innovation championship that we had hosted. Atal Innovation Mission has a partner in CGI, which is a large Canadian software company. We had hosted a innovation competition. In this competition, there were 100 schools across Maharashtra, Telangana, Maharashtra, Andhra Pradesh, Tamil Nadu, and Karnataka. But these are the 100 lowest resource schools. So it was a competition among them. And it was an innovation competition. And Mitesh won that competition, right? The reason I showed you this video is because in our nation today, this is the kind of reception that an innovator can get. You may be curious, what was Mitesh's idea? Very simple idea. His idea was to personalize fences, like the fence of a farm, fence at the border of a nation, etc. he essentially personalized it such that if you're a farmer, this fence, if it is electrically charged, it will not shock your animal, but it will shock an unknown animal. For example, if you're on a border, and it will not shock your soldier, but it will shock an unknown soldier. And so, very simple idea, but articulated very well. Some very creative solution design around it, and lots of empathy, and a combination of empathy and also rigorous building of solution, and a lot of confidence in telling the story, and so on. So this is the moment at which we stand as a nation, that in many parts of our country, with somewhere close to 10,000 tinkering labs and so on, there's beginning to be celebration of innovators, right? Now, the question is, of course, there's one question as to what will happen to Mitesh's idea now. Will it go forward? Will it remain an idea? If it has to go forward, how does it go forward? What does he have to do? Who will buy it? How will we connect him to the buyer? Who will pay for it? All of these, there are so many different ideas, so many different questions around taking such a winner forward, right? So in other words, what I'm trying to say, and it was told by Geeta ji earlier, that with these hackathons, all of us have realized that it's one thing to do ideation and generate a lot of ideas, but the real success lies when you combine when you multiply the ideation with the execution, right? A successful execution of that idea is what leads to successful innovation, and that's where formats like the one you are in to take ideas forward, right? There's a multiply sign between ideation and execution here, because if any of them is zero, any one of them is zero, then the innovation is zero. So I think the question is, now that you have a great idea, how do you take it to success? And I want to share with you some 7 steps that I have come to observe are useful in taking ideas, turning them into great innovation through execution, right? So the first idea is, the first step is to articulate the problem well, right? Because 50% of the success is in articulating the problem in a right way. You will appreciate that if you look at our schools, right, they don't teach us how to articulate a problem. They usually teach us how to articulate a solution, how to articulate an answer. Somebody will teach you solution, that is the teacher usually. Then they will write a problem in an examination, and then you will, and they know when they write a problem that you are already taught the solution to this problem. And then you answer, then you write your answer that they have already taught you, and then you get your grades. Now, in most of the real life, it is exactly the opposite, right? Solutions don't come before problems. Problems precede solutions. And when problems come in somebody's life, they usually don't know what the solution is, and the solution has to be created. So this whole idea of actually identifying a problem and articulating a problem, and I know you are probably the people in this audience, as far as this hackathon is concerned, you have already done that job already. But I want to assure you that articulation of a problem and re-articulation of a problem until you really have the problem in sharp focus is something that is a process that you will have to keep at, and you will have to be ready to refine the problem again and again and again and again and again, so that you really arrive at a problem saying, this is really the problem, this is squarely in focus now, and this is what I'm going to work on. I want to say two more things about this. Toyota had this beautiful training process. What they used to do is, when you join Toyota, the car company, and when a new trainee joins, they say, okay, well, we will take you to our factory, and we will take you to a particular operator's machine, where the operator is working on a machine, developing some part of a car, right? Generally. And then this person is taken to that machine, and they are said that, why don't you write notes about what you observe? And this person writes notes. And when they come back in the evening, they said, okay, well, your day is done. Why don't you go home and come back? And tomorrow, when the next day the person comes, they said, okay, we'll take you to the factory. They take you to the factory. You sit down at the same station, same workstation. You observe. You again write. They say, why don't you write notes? This whole thing goes on for one whole week, right? Then, at the end of that week, they ask the person to compare the notes they wrote on the first day and the notes they wrote on the last day. And he or she will see that there's tremendous amount of refinement in their observation of what they have seen, what works and what does not work. And the idea behind that exercise is to tell somebody that, look, what you glean is not what the problem is. There is a difference between seeing and observing, right? And the problems need a lot of observing of that kind. Now, sometimes you get lucky. Sometimes the problem you have is so unique, or the problem you are seeing in your surrounding is so unique, that the rest of the country, rest of the world, they have not seen it yet. So, for example, we were recently in Srinagar. There were these kids who worked on the problem of carbon monoxide poisoning in these homes, right? So they built in mountainous regions where people use firewood to keep themselves warm. They often at night, the firewood, the fire may be gone, but there's carbon monoxide emission. And if all the doors and windows are closed, people can die from carbon monoxide poisoning. This is a silent death. What these people did, these kids, they said, for this problem, we are going to build a carbon monoxide sensor, some detection of a threshold through, like a mobile phone type of an algorithm. And then when the carbon monoxide poisoning reaches a certain threshold, they motorize the windows and open one of the windows so that there's no poisoning from carbon monoxide. Carbon monoxide escapes, right? Very unique problem. This is a problem that most of the country does not know about. So many times you get lucky and the problem articulation becomes a little easier because this is a problem uniquely observable to you. But even after that, you still have to articulate the problem well. So you might say, okay, I understand, I get it. But what is a good articulation of a problem? So let me tell you 5 elements. A good problem generally has 5 features. A well-articulated problem. It has a goal that you're trying to reach, right? That is the first element. It has some understanding of a gap. That is, what is the current state of the system or the current state of affair? versus the goal, right? So it has some understanding of a gap. It has it is stated in a quantifiable way. Now, everything you can't quantify, but at least you know when you do something to solve it, whether you are going in the right direction or not, right? So if it is quantified, it becomes much better articulated problem. That is the third element. So far, goal, gap, quantification, right? Fourth is, it is a narrow enough problem that you can do something about it. You can't really do, you can't say, well, my problem is that I want to combat the climate change. Well, that is a good thing, but it is not an easy problem for one person to solve. So it is narrow enough. And the fifth piece is, it is neutral. In other words, it is really stated as a problem, not as a solution packaged into a problem, right? So if I say, well, the problem is the population, for instance, a large population. Now, no, you've already started to talk about a solution there. Somebody's echo is bothering us. Can people go on mute other than me?
So we have muted the participant. You may please carry on.
Okay, good. So the 5 elements are goal, gap, quantification, narrow, and neutral. In other words, you're not packaging solution into a problem. You can't say, well, the problem is there are not enough EV cars. Well, electric vehicles. Well, that's a solution, not an articulation of a problem. So sometimes, if you now when you read the newspapers, you see if there are some well-articulated problems. One beautifully articulated problem in our history of our recent history of our nation that a lot of you know about is, if you say that I want to double a farmer's income by, say, 2030, then that is a beautiful problem articulation, right? Because there's a goal of doubling. There's a understanding of some gap, which is wherever you are, I want to double you. So there's a gap and a quantification there. If you say by 2030, let's say, then you have put some time frame on it. It's narrow, and it's really only one thing you're trying to do: double the farm. Now there are many contributors to this, to getting there, but it's a beautifully articulated problem, right? So articulate the problem well. Think about the goal, gap, quantification, narrow and neutral, right? Let me go to the second piece. Once you have the problem well in focus, or as you build and you refine your problem, then there's a question of building a solution. Here, you will design, build, and test, and then wherever it does not work, you redesign. I was talking to you about iteration. In this phase, you are going to fail, and the idea is to fail quickly and iterate fast, right? And arrive at a solution, and don't be shy about failures. It's okay. This is what the design phase is for. Sometimes people do use some wonderful means to accelerate their failure. So, for example, they use simulations. And since I'm using this example because you're with CSIR, and CSIR scientists know this very well. But you may be working on a problem. Let's say you are working on a problem of reducing car accidents, or reducing accidents on highways, let's say. You can't go and wait for accidents to happen, right? To test your system, but you can simulate. a situation like this. I was recently meeting these two girls. They were they told me about this very interesting problem that I hadn't thought about. They said their parents worked in firecracker, the fireworks making factories in Sivakasi, right, in Tamil Nadu, where there's the largest concentration of making fireworks. Their parents work in these factories, and they knew that the highest possibility of an accident is when they are mixing chemicals by hand, right? So when firework is being made, some wrong proportion of chemicals, some wrong mixing of chemicals, and it sets ablaze the whole factory and the neighborhood. And this can happen very easily. So these kids, they were obviously they can't wait for such accidents to occur to test their solutions. But what they've done is they have actually they were trying to build these cement mixer like drums so that the chemical mixing part of the whole design process of a fireworks, that part becomes more safe and secure. So instead of designing the drum over and over and over, which they could have done, but it would take much more time and effort and money and everything, they decided to simulate the drum chemical properties, the properties of the drum, the angle, the rotation, and they calculated the probability of how likely it is for fire to occur when you make certain mistakes. Right. So a beautiful problem to simulate, first of all. And when you're doing it in simulation, you're doing it in a much more safe manner. And at least 80%, 90% of your learning can come just from simulation. So I think the second thing is to sort of design using clever means, build a solution, work on what you've designed, test it. Again, testing can be through simulation and redesign and iterate, right? Number three is, and this is when we start to go away from the lab. So I know that your hackathon has a large lab component, but what happens after the lab? So number three is to know what value are you creating for somebody for whom this solution is, right? Now, this idea is an important idea because see, we celebrate today. We celebrate unicorns in our country. You cannot capture. You cannot get back the value. If you don't create value, you can't get any value back into your pocket, right? That should be clear. It's important to know what value is being created for somebody. Unicorns, when you say that it is $1 billion of a market creation, they must be creating much greater value, more than $1 billion, so as to capture billion into their own pocket. So the idea of, like, when you go to see a cricket game, for example, and you buy a ticket for so much money, clearly your valuation of that experience is much higher than the value you are paying to buy that ticket, right? So the idea of knowing that how much value you have created is important in order to know how much of that can you get back for your own business, right? Now, the question is, how do I know what value I created? The one way to know it is to say what was happening in the absence of your solution. How was a given problem getting solved? Like before we created metro rail in a city, let's say you come from Delhi. Before metro rail, how did people travel? How much time and money did they spend, right? And then, given that, after you created Metro Rail, how much reduction in time happened because you have created the Metro Rail? That reduction in time on average, how much value do people assign to that much time? You may say, what is the average wage? And if the average wage is so much, and if I say I saved an hour, I've saved that much money for this person, for the government, whatever. And therefore, can I charge a portion of that? That is the thinking here, right? So any solution you are working on, it's really important to know whose problem you're solving and how much value have you created for them. This is easy to often lose sight of when you get really excited about the technology and you start going in that direction. And often, whether the person for whom you're creating it, do they value it or not, can be lost. So that's the third piece. The fourth piece is, can you capture some of this value into your pocket, right? If you can't capture some of the value into your pocket, then you can't run this, you can't grow this, scale this innovation forever. Now, this idea too, sometimes when you are a new innovator, especially if you are interested in social impact, sometimes it feels like, do I really need to capture anything? I'm not here to make money. Now, I'm not saying that, and that's a great mindset, by the way. Don't solve a problem just to make money, right? I mean, solve a problem because it needs to be solved. If there is an important problem to be solved and you solve it, people will give you money. Don't worry. The question is, how do you capture some of that money into your pocket, right? And that's where the idea of business model comes. So you see various types of business models, right? For instance, there's a pay-per-use business model. When you use Zomato, when you use Uber, etc., you are paying something every time you use it. On the other hand, if you have a cable subscription to watch content, that may be a more monthly subscription type of way of paying for it, right? If you go to college and you pay for the whole year, that's another way of paying for something. So there are many, many ways in which people monetize, people capture some fraction of the value they have created for themselves into their pocket. You need to begin to learn that. Now, in today's world, there is a lot of help online to understand how to do that. But if you're at an early stage, this is an important piece to know, that you have created some value and you know how to capture it. It will also require a lot of experimentation in the market, etc., once you have a working solution and so on. Right? Number 5, tell a great story. There's no way around this. Oftentimes, again, there's very little emphasis on telling a good story. But all great innovators, all great scientists, all great academics, all great business people are great storytellers. Okay, and there's a way to learn it. I hope the hackathon will teach you this, and if not, there's online material that you can go and say, how do I pitch my idea? And the elements are very simple. What problem are you solving? Why is this an interesting and important problem? How are you solving it? And what is the value you are creating for people? So this few basic elements, if you get it together and learn to tell a good story, that will go a long way. You should be able to do that in half a minute, as to what you're working on. Now, initially, this may be tough because you're still thinking that, well, I'm even figuring out how this works in the lab. Why are you wanting me to tell a story? But there's nothing stopping you from making a story alongside, right? So learn to tell a great story. 6, think global from the get-go, right? Many of our problems, the fascinating thing about solving problems in the Indian context is that many of our problems are so on one hand, they are solved in some parts of the world. So in our healthcare system, there may be problems that are solved somewhere else. In our energy systems, there are problems that are solved somewhere else, and so on and so forth. So many of our problems may be solved elsewhere. But because affordability, solving it in an affordable way is very important to our country, when you will solve your problem, many parts of the world would want it because everybody likes affordable solutions. So think about how big of a problem this is globally from the get-go. I'm not saying change your problem, but keep your perspective global. Many times, many times, what happens is that you start discovering a problem in India, but then you realize that this is a giant global problem, and you will have to think about the nature of it, global nature of it from the get-go. And that will change the way you design. I won't really go into this too much because I know this is way downstream for you probably. And then the final thing I want to say is don't give up. What I have found, and I told you this earlier, solving any problem in a way where you make an impact, it takes easily 5 to 10 years. Even the fastest growing technologies have taken that much time. If you look at UPI, for instance, in our nation, it took that much time, right? So any Aadhaar, it took that much time. These were the fastest growing trends actually in our nation. So anything you take up that's worthwhile will require that kind of commitment, and be prepared to commit there. I'll tell you one example of one of my own students. He came as an undergraduate student at MIT, and he was very interested. And we sent him to Africa as a part of one of the student programs. He went there, and he realized that there is so much agricultural waste all around Africa. What do you do with it? So he started. Well, he was a mechanical engineering student and was also learning. He had a minor in chemical engineering, and he started to learn what to do with this waste material and so on, and started to work on combustion, and started to build these densified pallets of this agricultural waste, just like charcoal. But densified, energy-dense pallets of this agricultural material, and started to sell it as cooking fuel. Then alongside, he realized that, well, actually I can do this on a small scale, but when you have to do it on a large scale, the problem is not the densification of the agri-waste. The problem is how do you collect the agri-waste? Because it's all distributed all over all these small farms all across the country. How do you gather it? It's so expensive to gather it. So originally his idea was that he will have a plant where everybody will bring their waste, and he will turn them into pallets, and he will sell the pallets into the market. But he realized that nobody is willing to bring their waste all the way to the plant because transportation is a problem. So he pivoted. And he said, well, what if I instead of me designing a plant, what if I design a tractor pulled small unit which can go to the farm, and the farmer can put their agricultural waste into it, and I will make pallets and give it to them, or give it to the village, and then they can use the pallets. So he started to design that unit that is pulled by the tractor. That worked. But then there also he realized that, well, the tractor fuel, the tractor maintenance, the number of tractors you need, that tractor pulled units you need, all of that is a massive logistical and expensive exercise. And in selling the pallets, which are substitutes to the charcoal is a climate change problem. In selling these pallets, there is not a much traction, and people are not really paying because it's not a very high value product and so on. So you can't really have a business around this. So slowly started to experiment with the combustion process itself. And he realized that if I can not cook the agri waste so much, instead of the palletization, if I can leave it at a previous stage, so that it becomes fertilizer, this what we call the biochar, right? It remains in a fertilizer stage. In that stage, first of all, he would have wasted less energy in densifying the agro waste, but he would also have produced fertilizer which the farmer is willing to pay a little more for. So that is what they ultimately pivoted to. That company today, it's about 12 years from the time I started with him, right? 12 years fast forward today. That company known as Takachar, you can look it up, Takachar. They won the Earth Prize, which was $1 million prize, and they're doing good business in India and Africa, right? But the main reason to tell you this story is that he didn't give up. He knew this is an important problem to solve, and he's going to do what it takes to solve the problem. I think in your problems that you have picked, you're going to find such problems. And the idea is to just stay with them and solve them until they, whatever it takes, right? So that's all I wanted to share. Once again, articulate your problem well, iterate on a solution, and then endure through this whole journey. And I think then your hackathon will lead to a wonderful innovation that will impact the world. Thank you very much.
Thank you so much, sir. If any student has any kind of query, he or she may raise their hand. Yeah. So the one student has raised his hand. R. Sai Pranav.
Namaste, sir. My name is R. Sai Pranav of Class 8 from DA Public School, Hyderabad. So I have a doubt for you, sir.
Yeah, tell me. Sai.
So my question is, what is the relationship between creativity, innovation, and design? Like
creativity, innovation,
and design.
And design. Okay. Oh dear, you asked very hard question, Pranav. Well, innovation. Let's take innovation first, right? Innovation as a word comes from a Latin word called innovare. Now, what it means is to renew, to make something new. Okay, so if you solve a problem in a new way, or you do something in a new way than what has been known to us, that's when innovation takes place. Okay. The idea of design is related to innovation, but it doesn't have to be always innovation, right? If you look around, everything that you see that is not created, that is everything that's not natural, like say mountains, lakes, plants. These are natural things, right? Everything that's not natural, that is this bottle, this phone, everything that's not natural is designed by somebody like you and me. right? That's how it came about. The idea of design is to give some material, some kind of a form, some kind of a shape, that is this, right? And some kind of function, something to do. Like this bottle, we said, I'm going to take plastic and I'm going to turn it into bottle, and then it will have something to do. It will have something to, I mean, it will be able to carry water, right?
Sir.
So that process of doing that is design. Now, the third word you used was creativity, right?
Yes, sir.
Creativity is the ability to create. So now, create what? It may be create these types of things. It may be create words. A writer's ability is to create stories. A mother's ability to create. What do you like to eat? What does your mother make really good that you love? Pranav, what do you love? What does your mother make that you love to eat?
Sir, biryani.
Biryani. So ability to make great biryani needs creativity, right? Ability to create, that's creativity. Is that good?
Yes, sir.
Great, thank you.
Any other query from any other student? Yeah, there's no. Any other query? So I guess there are no more queries right now, sir. In case there are more queries from any child, we'll come back to you, sir.
Oh, certainly.
Thank you, sir, for sparing out time from a busy schedule to help out the students and give them the right direction. I believe your encapsulating talk on innovation was very insightful, motivating, and helpful to the children. I would also like to thank the head HRDG for steering up the entire CSIR-Jigyasa Epic Hackathon and providing us the required vision and direction. Under her leadership, we have been able to successfully implement this program across CSIR. I also thank the mentors, Jigyasa coordinators, and other CSIR scientists for joining this program. Thank you, students, for attending the event. Hope this talk was helpful to you. Thank you all. Have a great day.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am. Thank you, sir.